So we want to take the fourth derivative. Okay, so we're going to say f prime of x is equal to 2 times 6 is 12, x to the fifth plus 10. So that's the first derivative. The second derivative is going to be 60x to the fourth. I think I'll just write it the next one here. The third derivative of x, okay, is going to be 240 x to the third, and then our fourth derivative, and I'm just going to write it up here. Okay, that's supposed to be a 4 right there. It looks kind of like a 9, but it's supposed to be a 4. Okay, so the fourth derivative, we're going to take the derivative of this guy right here. And, let's see, 20, 12. Trying to do that math in my head here. Okay, I believe that's going to be 720x squared. Okay, so that would be the fourth derivative. All right, moving right along. So hopefully you're getting the hang of these derivatives when they say higher order derivative. Now there is a reason why we need to at least find the second derivative in the applications under finding the concavity. Remember, the first derivative we used to find critical numbers with and find if our function's increasing or decreasing. I don't know if you've already done that yet or not. I can't remember. Okay, anyway, let's say we have f of x is equal to 10x cubed minus 10. And we are asked to find, that's right, the fifth derivative. Okay, well, the power only goes to 3. So if you start taking the derivative, you remember you subtract 1 from the power every time you take the derivative. So if you took the derivative, took the derivative, took the derivative, we should end up getting down to 0 there, but I don't know. Let's just do it real quick. F prime of x is equal to 30x squared. F double prime of x is equal to 60x, and the third derivative is going to be 60, and then the fourth derivative is going to be equal to 0, and then for some who knows what reason in the universe, you need to take the fifth derivative, right? The derivative of 0 is 0. Okay, so there you go. So you see this on a test, you know, it's kind of like, oh well, this is going to be 0. I mean, you subtract 1 every time you take the derivative. We got to 0 on the fourth derivative here. So if this is a 3 and we're going to 4, you know it's going to be 0, right? So just add 1 to this exponent right here and you'll know that it'll be 0. Okay, you see the pattern? Alright. Yeah. Oh, let's see here. Let's work a little bit more difficult one. We got to use some rules. We're going to do one where you got to use the product rule here. So we have x. So I guess this is kind of a little refresher here of taking derivatives, huh? Alright, and we are asked to find, we want to find the third derivative. Now instead of writing prime, 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 I'm just going to write a 3 up here. The third derivative of x. Alright, we don't normally write it. We don't write 1s or 2s, but I guess we could write a 3. Third derivative. So we're going to take the first derivative, right, using the product rule. So the derivative of x is 1. And of course, we just rewrite everything. Rewrite that second function, plus rewriting the x. I'm going to go ahead and take this 3. We're taking the derivative of this piece here. Take the 3, bring it out front. Rewrite what's in parentheses. Subtracting 1 from the exponent, so that becomes a 2. And of course, you take the derivative of what's in parentheses, but the derivative of what's in parentheses is just 1.